Hello everyone and welcome to today's webinar. Thank you for joining us today for our augmented and virtual reality empowers education and research, a hands-on webinar on how to transform into Classroom 3.0. My name is Britta Källström and I'm the Global Marketing Director at E.ON Reality and will be acting as your moderator for today's session. We have a big group today from all corners of the world, and just to let you know that we are today webcasting from Sweden and from Singapore. Before handing things over to our presenters, I'd like to let you know that there will be a Q&A portion following this presentation. However, should you have any questions during the session, we encourage you to submit them in the chat box in the GoToWebinar panel, and we will get to them later today. Also, I would like to let you know that we are recording this webinar and we will share this in a link following up with an email afterwards. Now, without further ado, I'd like to introduce our presenters. First, we have Professor Bertil Andersson, who is a prominent biochemist from Sweden, and he has won the Wilmer Exner Medal in recognition of his research in biochemistry. He joined Nanyang Technological University, NTU, in Singapore as its provost in 2007, and in 2011 he was appointed president. And during his time as president, NTU moved from 74th position in 2010 to 11th position in 2017 in the QS World University Rankings, making it the highest ranked Asian university. Before Professor Andersson joined NTU, he led the European Science Foundation in Strasbourg, France, as its chief executive from 2004 to 2007. He has also been associated for several decades with the Nobel Foundation and served as the chairman of the Nobel Committee for Chemistry in 1997. Professor Andersson currently serves on the board of directors of KTH, Kungliga Tekniska Högskolan, that's the Royal Institute of Technology in Stockholm, Sweden. We also have Terence Petit, E.ON Reality's pre-sales engineer, who is based out of Singapore. He started at E.ON in 2011 as an intern and then joined as a full-time employee 6 months later. And he has worked in research and development and participated in the development of the AVR platform and created AVR product that we will learn more about here today. He has now transitioned more into sales, where he handles the education, medical, and transportation sectors. And he has a master's degree in computer science from the University of Bordeaux in France, with a minor in virtual reality. And with that, I would like to turn it over to Professor Andersson. Unfortunately, we just learned that he had to cancel his participation today due to a last-minute change in his schedule. He sends his sincere apologies that he could not attend in person today, but he has prepared a short 10-minute presentation, and here it is.
Okay, welcome to this presentation on E.ON Education and Classroom 3.0. And of course you realize it is about the future education and it's about the classroom of tomorrow. Education go through big changes. I would say more changes than ever. And it's driven by new pedagogics. It's driven by educational technology. And E.ON Reality, who is a company for virtual reality, is a major player in this exciting development. My name is Bertil Andersson. I'm a professor of biochemistry. Been in Sweden most of the time at Stockholm University. I was president of Linköping University in Sweden. I also was the director of the European Science Foundation and worked on the pan-European level before. I also spent a lot of time in Singapore for 11 years as president and provost. But today I'm the chairman of E.ON Education and its council, and that is a task I look really forward to. As I said, I spent 11 years in Singapore and in Asia. And the task there was to transform a university, transform Nanyang Technological University. And I of course, reformed research. We recruited many top professors, and we went up in all the rankings. But the point today is that we also totally reformed the education and to what I call modern education. And in that task, we worked with Eon Reality in Singapore, and they helped us to introduce the modern technology to our classrooms in Singapore. And that was a very creative collaboration. And I always, when I talk about education, I talk about Classroom 1.0. I think every one of us have a picture of our own classroom that we have been to school and universities and so on. And this traditional classroom is still the norm. Students sit as passive consumers of lectures with a teacher in front of them. And of course, the content is presented in a 2D setting. And university professors are very creative and innovative in research. We all know that. But it's a little bit strange that professors are also very traditional in their teaching methods. So therefore, the Classroom 1.0, white chalk and blackboard, is still used in many instances. But today, as I indicated before, there are challenges to traditional teaching approaches, and particularly in the last 5 to 10 years. You have, of course, heard about the MOOCs, that some universities or knowledge providers around the world give world lectures on MOOCs that anyone in the world can take advantage of. Another trend that is very important is what they call the flipped classroom, where students sit together for team-based learning with all the computer-assisted of the knowledge. Some people call that Classroom 2.0, just to distinguish it from the old traditional classroom. So I always say that today in schools and universities, we are going from Gutenberg to Gates. And again, this is the Classroom 2.0. It's ICT supported, all lectures are online, and professors are still important, but maybe the most important professor is Professor iPad. Lectures are replaced by tutorials in group setting. This is actually how it was in the old days in Cambridge and Oxford. There were tutorials, there were no lectures, and in a sense, we are going back to that. Team-based learning is very important. Students should not be consumers of lecture, they should be active in the learning process. So it changes the role of the professor. He's not a lecturer anymore, he's a facilitator of the team-based learning. So in NTU, where I had the privilege to work, we made this transformation very smart. We changed more than 200 smart classrooms. We reduced the numbers of traditional classrooms. And I would argue that today NTU is one of the leading universities in the world that has taken education one step above the traditional education. And in doing so, we had a lot of collaboration with Eon Reality. We know, of course, that technology and computer science changed our societies. And the same is it with education. And this, I predict, will go on and on. We only seen the start of it. And virtual reality, I think, going to be added to what I had before and provide the tools to what we now can talk Classroom 3.0, going one step further. And of course you could say, oh, virtual reality is high-tech, very complicated. At the same thing, learning in 3 dimensions is the natural way of learning. The world is in 3D. The real world is in 3D. Our eyes and brains give us a 3D picture of the world. At the same time, traditional teaching is based largely on text and 2D images, on pictures or in computer screens, but still 2D. And I would argue as a professor that the abstract thinking that we good students have is when they can transform these 2D images to 3D images and to understand the chemical content or the structure of an equipment or something like that. And of course, when humans invented written symbols, text, and of course later books, it was crucial for communication and documentation of facts. You could even say it's been a base for our culture. But that does not mean it is perfect for education. Because 3D images are crucial for understanding concepts in an area of academic disciplines. Biomolecular structures, DNA molecules, ribosomes, for example, in medicine and human body and its organs. And actually, virtual reality has come very far, in particular in the areas of medicine. Chemical molecules and their interactions, atomic structures in physics, ecological systems, and environment. Needless to say, engineering devices and systems are 3D. Again, architecture and design, 3D, of course, urban systems and dynamics. And it's always, for all these areas, it is a challenge to understand these if you only have access to 2D. So, my view is that the Classroom 3.0 is a must for the future. But there are challenges to establish that. I have already mentioned the conservatism. Classroom 2.0 is still in its infancy. Still, the old Classroom 1.0 is very abundant. It's a cost, of course, it's high-tech costs, and the academic systems normally don't have a lot of money. There's also what I could call a bottom-up resistance. Professors are taken out of their comfort zone. They know how to give a traditional lecture, but using virtual reality as a tool for education doesn't come easy. The professors have to also to be educated, and that is very important in this transformation to the Classroom 3.0. We also need a better integration with 3D technologies and the forefront of learning science in an interdisciplinary way. I think we also require for the future more versatile 3D content. We need more research on how to educate in the new mode. And what I think is very important and excited, that Eon Reality as a company will actively contribute to these important processes. So therefore, Eon Reality will bridge the gap between technology and education through the establishment of a new non-for-profit organization called Eon Education. To this end, I have been asked to chair that and chair an advisory panel. This panel is going to be at the end about 12 high-level academics. Today we have already 6 people, very high-level people engaged. So the vice chair is Iron Rensburg, who was the previous president of University of Johannesburg. That is an expert on Africa and a super expert on education. I could also mention Jenny Higham, who today is the principal of St. George's University of London, which is a major medical school in London. And she is expert on virtual reality and medical education. And there are other people here that are going to contribute. So what's going to be the mission of Eon Education? I already mentioned develop the interface between education and technology. And there is a gap between these two that has to be bridged if 3D technology are going to have a function in a classroom. Further develop 3D content and pedagogics. Doesn't come easy. One has to work on that. The Eon Education is going to lead seminars and workshops in this area on a global scale, I would say. You will probably hear more of these webinars in the future. We should also play advisory role, advisory role to the technologists, but also to the professors. And we also see a special mission in Africa. I think Africa has an educational challenge. And I don't think we can rely on traditional school, but actually use creative technology to help the education challenge in Africa. So EON Reality has already come a long way. And it's already today, and that's important to stress, world leading when it comes to a library of 3D academic content. And that content is, of course, in all the areas I mentioned before, medicine, chemistry, physics, engineering, and so on. But I think it's nice also to mention that in humanities, there are also 3D content for education. And here's one example from the Canton province in China, where it was a technological development in these early days in Canton, which I think is very interesting. So with that, I just thank you for your attention. And my last statement here, 3D virtual reality is high-tech, super high-tech, but it is at the same time the natural way of learning. Thank you very much.
Great. Feel free to send over any questions or feedback on Professor Andersson's presentation, and I will make sure to forward them and follow up on those remarks. I will then hand over to Terence in Singapore. Terence, the floor is yours.
Thank you, Britta. So thank you all for attending this webinar. What I'm going to talk about to you today is sort of a continuation of what Professor Andersson just mentioned in his presentation, which is how do we at EON Reality sort of answer the challenge of bringing AR, VR, and 3D to the classroom in such a way that teachers don't need to have all of that technical knowledge that we might think they need, and to be able to develop these kinds of contents easily and just publish that very easily to their students. So let's go through it. So what I'll do is I'll first go through a series of slides just to present the platform a little bit, and then I'll jump into a sort of a live demo of one aspect of the platform, which is a mobile app that we call Creator AVR. So that's mostly what we'll be focusing on today. All right, so some background to the platform first, on top of what Bertil Andersson has said already. So of course, what we've noticed in the past few years is a growing technology integration worldwide in all areas of life, which means that everybody nowadays, or rather in every sort of domain that you look at, you see technology taking over and 3D technologies, virtual reality taking over. However, at the same time, we have noticed that this is still lacking in the education sector. And we would like all universities across the world to be as much on the forefront as NTU in Singapore is. And that's what we want to bring to the universities worldwide. And there's a quote that I like from an organization called the Super School Project that says, "We've gone from the Model T to the Tesla and from the switchboard to the smartphone, yet high school has remained frozen in time." And we think that's true as well of universities, but also any sort of educational field that you could think of. Of course, we can fix that because the majority of people nowadays, students, but also people in general, have smart devices. And these smart devices are all capable of displaying 3D content, unlocking augmented reality content and applications, and allow you to experience immersive virtual reality applications as well. And so, of course, this constitutes a huge potential for training that we think as of yet has not been tapped into, or not enough at least. So our solution to that, of course, is the AVR platform. Now, what the platform is, just a short paragraph of introduction here. It's a platform for non-technical teachers and educators to upload 3D content to their library and create immersive, augmented, and virtual reality applications in minutes without any sort of programming knowledge or anything like that, and then just publish that right away to their students and have their students experience these 3D and augmented reality and virtual reality lessons from their devices right away. So a few words about the platform before I delve into more detail. Some of the main functionalities or features. So first of all, it's a platform, of course, that supports virtual reality. So we make use of multiple devices from head-mounted displays like the Oculus and Vive to smaller devices like Android and iOS smartphones. So today we'll focus on the smaller devices. It supports augmented reality as well on smart devices, but also on smart devices like smartphones, but also on AR glasses. We've seen in the recent years a real boom of smart glasses that use augmented reality technologies. It's multi-user, which means that you do have that collaborative aspect as well, where multiple people can collaborate with each other. So a teacher can, for example, host an online session and have their students join in. So we'll see more about that later. It's cloud-based, which means that it can be accessed anywhere from a smart device as long as there's an internet connection. There is a content library, which means that when we roll this out, each school or each university will get their own content library that they can manage, where they can put their own users, their own contents, their own lessons, and choose to have this be private, where other universities or external people cannot look into it. And it's brandable, which means that when we roll this out, the university that acquires this can make it look the way they want. They can have their name on it, their logo, and everything. Okay, now let's look at what a typical package for the EON AVR platform, focusing on Creator AVR, the application, would include. So first of all, we have what we call the core AVR platform components, and there are 3 of them. Number 1 is the AVR portal. And what this is a content management system. And this is where your university's library of content will be stored. So you've got your teacher accounts on there, your student accounts, your library, like I just mentioned, with your models and your lessons, and your Creator AVR desktop, which is an application on the desktop for teachers to easily create lessons. Now, just a word on the library itself. Of course, schools have the ability to upload their own content, which is the main sort of powerful feature here, the main attraction. But we do ship this with existing contents, and here's a tiny sample of it. So we've got some 3D models in marine engineering, in the medical field as well. Engineering here, you can see a whole bunch of different engines and different objects like that. Geography, and mechanical engineering objects as well. And this is really just a tiny sample of the hundreds of objects that we ship along with the platform, which represent thousands of man-years of work. Let's go back here. So that's the first part of the AVR platform core components. Number 2 is the Creator AVR mobile application. So that's what I'm going to be demoing or demonstrating to you later on. So this is an application that students and teachers log into, where teachers can create AR and VR lessons. They can do that on the desktop computer as well, but if they choose to, they can do it on the phone. But the main aspect here is that students log into their accounts and they see the whole library of the school that they belong to, and they're able to experience all the lessons and all the content that was added there by their teachers. And as well as that, the application displays the school's dedicated website, which is where the library of content is displayed. Next, we have the AVR collaborative module. So this goes back to the multiplayer or multi-user functionality that I mentioned earlier, which is where a teacher can actually host a collaborative session with their students and have the students log in from different parts of the world, as long as they're on their smartphone with the Creator AVR app installed. And so that you can have this sort of virtual classroom environment where the teacher speaks to the students can hear what the teacher is saying, the teacher can give the floor to one of the students so that the student can now have control of the application and make everybody see what they're seeing. So it's a very it's a very new way of teaching, I would say. So those are the core components. Now we do also have the advanced tools. I won't delve into too much detail here because this would take a very long time. This would be more for teachers who do have some experience with programming or 3D creation. So number one is a plugin to 3ds Max that allows to export any 3D file format into a file format that's understood by Creator AVR, and then just directly upload that to your school's library to be able to use those contents later on in your lessons when you're creating them. And then we have Eon Professional, which is an authoring tool that allows you to create standalone lessons and this is really if you have sort of programming knowledge or at least an understanding of programming logic. But this can be learned by anyone, really. And the last thing here is just small accessories called the Homido Mini, and these will be clipped onto your device so that you can experience as a, I'm saying you as a student now, so that the student can experience the virtual reality immersive mode of the lessons created by their teachers. Okay, so we can have a quick look at the platform architecture, but let's not delve into too much detail here. So we have a client front end. This is going to be the mobile devices on the one hand, and the web interface with the AVR portal on the other hand. So mobile devices, of course, this is the application, and the AVR portal is the content management system, the library. So those things are connected to some web services at the back. So when a student goes through a lesson on the application, which I'll show you later, everything they do, all the questions that they answer, all the things that they try to perform are being recorded in real time and sent to the server so that that data can be harnessed later on and used in a relevant fashion to create understandable data for the teachers to know how well their students did or which students need some more help with which lessons, etc. And then behind, of course, we have the content repository and the database, and that's where all the actual content will be stored and accessible through the cloud from anywhere. Okay, now let's take a look at the two core components of the platform, AVR Portal and Creator AVR. And then once we've gone through these few slides, I'll just jump into the actual demonstration to show you how the app works from the student's perspective. Okay, so AVR Portal, like I mentioned earlier, is a content management system, and it's a desktop accessible platform for teachers and admins to manage their school. So what can they do on this? Now, if you look at the interface here, we've got 5 different tabs at the top, and these are 5 tabs for 5 different aspects of content management. So the first tab is the admin tab, and this is where the school's admin will go in and modify general settings like the school's name, the school's logo. They can manage their account privileges there, which means that the admin can decide for a certain type of account, like a teacher account, what are the things that the teacher can do on this platform? Are they able to create a lesson? Are they allowed to upload new objects? This is all customizable by the admin. As well as that, the admin also does have a view of how many of the school's accounts have been used up so far. Next is the People tab. Now this one will also be accessed by the admin, or accessed by the admin rather. So this is where the admin will be able to manage the users of the school. So teacher users, teacher accounts and student accounts. So he can import accounts, add them, delete them. He can create student groups. He can manage all the assigned courses. So this is where that will happen in the People tab. Next, we have the Content tab, and this is one of the tabs that the teachers will have access to. Now, the teachers here in the Content tab will be able to manage the categories of the lessons, create new lessons, manage their courses, create new courses, and the way that they create lessons is that they choose a 3D model from the library and they start building a virtual and augmented reality lesson on top of that. So we have a really easy interface to use. It requires no programming knowledge at all. That's where that's going to happen in the Content tab. Next, we have the Assets tab, and this is where the 3D models will be stored. So these are individual 3D models that can be used inside of virtual and augmented reality lessons. And this is where they're managed. So I had mentioned earlier that when we roll this out, we include hundreds of existing 3D models, but the main power of this platform, of course, is that teachers do have the ability to upload their own 3D models. And so this is where that happens. Finally, we have the Banners tab, and this one is accessible by the admin. And the admin here is able to customize the way that the library will look to someone who logs into it on the phone itself. And so this is where a bit of the customization work comes in. And so this is what it might look like on the phone, for example, where we have the banners at the top, and the banners are, of course, modifiable by the admin, and he's the one that put them there. He can link the banners to a certain lesson, for example, if he wants to advertise a certain lesson or a new course for his students. Okay, next we have Creator AVR. So it's available, it's an iOS and Android app for teachers and students, mostly for students, because it's where they'll be able to experience their lessons. It's also available on desktop for teachers for the creation part, and it's free to download and try. So you can go ahead and pop open your App Store or Google Play Store and search for Creator AVR if you want to try it out. You'll log into a public account in that case. Okay, so Creator AVR for education, but also for enterprise, empowers non-technical teachers and trainers to create compelling AR and VR lessons. And so that's what you see on the right side there is an example of what a lesson might look like. And so the teacher who created this lesson had no sort of programming knowledge whatsoever, and yet they were able to create something in augmented reality where you are able to disassemble an object, see different annotations, and do a whole bunch of things that we'll see when I do the demo. So the courses and lessons created in Creator AVR can be managed from the AVR portal, of course, by the teachers. Okay, Creator AVR connects to your school's dedicated web interface, which actually what it does is it displays the contents of your school's Creator AVR library. And like I just mentioned, trial or guest accounts have access to a public library. So that's what you'll have access to if you just download the app. But if you contact us, we are able to set you up with a trial account where you can actually upload your own models. All right, so Creator AVR, as well as teaching students, also test their knowledge with customizable and scored challenges in every lesson. So when a teacher creates a lesson, they're able to add challenges as well. So we can see an example on the right side here. That's a quiz that a teacher prepared for their students. Now the app uploads data, like I mentioned, to the cloud as the students goes through a lesson. So every answer that the student answers will be uploaded to the server to be harnessed later as data. Just a word of the structure. The structure of the Creator AVR library is that the library is split up into different categories. Each category can contain multiple courses, and each course contains one or many lessons. Okay, so without further ado, let's jump into an actual live demo. So I'm going to go ahead and share my phone screen now. So you should be able to see my phone screen. There we go. So everything I do on my phone here, you will be able to see at the same time as I'm seeing it. So if you look at the bottom left there, so I'm using an iPhone right now, so this is the iOS version of the app. So at the bottom left is my Creator AVR app. So when I click on that, because I'm an existing user, I get logged in automatically to my school's portal. And here I can see all the content, all the lessons, and all the courses that belong to the school that I belong to as well. So here we are. This is an example of what a library might look like. So we've got lessons, courses, 3D models. At the top there, we've got 3 tabs. The library tab, the assets tab, which is actually just a list of all the available 3D models. So we can see that there are a bunch of them here. And then the third tab is the My Content tab. Now, if I'm a teacher, my content will contain the courses that I've created. And if I'm a student, my content will contain the courses that have been assigned to me by a teacher or by my teachers. Now let's go back into the library tab. We'll do this from the student's perspective. I want to show you what this looks like from a student's perspective. So we're going to jump into a lesson, and we're going to run the lesson and see what it looks like, how I can learn from it as a student. So let's see, we've got the first line there. The third course is called Jet Engines. Let's go ahead and jump into that one. So I've tapped on it. I get taken to the list of lessons within that course. So I can see that there are two different lessons here, gas turbine engine, air inlet, and turbofan engine. Let's click on the first one. All right, so it takes me to the intro page of my lesson. I can see my learning objectives there. Now these were typed out by my teacher. And then I can click on the play button to start playing the lesson. So I click on that. And so what it's doing right now is it's downloading all of the relevant data that this lesson requires to use in order for this lesson to be displayed correctly. So this, the data is, for example, the 3D model, the annotations that my teacher has added to the lesson, and all the different challenges and learning modules that they've added as well. So unfortunately, I can't broadcast the audio from the computer through GoToWebinar. I haven't found a way to do that. So just be aware that every time I click on a button, there is some audio feedback that I get as a teacher, as a student rather. So it's not a silent experience. All right, so let's, just in case, I'm gonna unsilent my phone in case you guys can hear anything. Okay, so I have my learning objectives here. I'm gonna click on the start button to jump into the lesson. So I don't know if you heard that, but there was some audio playing as soon as I entered this first screen of my lesson. I had some audio playing at the bottom there. I'll press start again so that you guys can see the progress bar at the bottom there. It's moving. Stop that. So this means that my teacher recorded some audio when they created this lesson, and they decided that I would hear that audio as soon as I entered the lesson. Now, before I jump into the various modules and the various challenges, let me just mention briefly the various navigation modes that I have access to. So here I'm in what's called the touch mode. So I can use my finger to rotate my model around like this. I can use two fingers to pinch and zoom in or zoom out. I can choose to make my model transparent by clicking on that button. I can also explode the various parts of my model out, just like that. I can turn on the annotations that my teacher added to this model. So the teacher has a very simple interface to create all these things. So I can see I have a very nice view of what each part of my model is called. And then the fourth button there, if my model contains some built-in animation using a keyframe, for example, if you guys know what that is, that button would be available for me to click on, and it would automatically start the animation of the model. And the last button down there is the dissection button, where I can turn that on and manually start dissecting my object, just like that, to really dismantle it. Now this is really cool in scenarios where you have like a human body, for example, where you can really take apart all the various layers. So this was more of an exploration mode, but if you look at the bottom there, you can see that it says intro. And so this means that I'm currently in the introduction mode of the lesson. But if I click on that bar, I have access to all of the different modules that my teacher added to the lesson. And so there's a very simple interface. It's kind of like a 3D version of PowerPoint for the teachers, where they can really easily add some new modules rather to their lesson. So let's take a look at a few of them. Now currently we're in the intro mode, the intro activity, I would say, because it's highlighted, so we can tell that we're in that one. But we do have a lot of other ones. So I can see that my teacher here really went to town and added a lot of different modules to this particular lesson. But let's take a look at a few of them. So let's go to number 1, compressor cover. So it takes me to the compressor cover part of the object. And I don't know if you heard that, but it also starts playing some audio that my teacher recorded. So my teacher decided that this activity would focus on that part of the model and start playing some audio. Now, if we look at the bottom right there, I can see that there's also a video that my teacher added to this particular part. So I can click on that button, and that's going to start playing the video that my teacher attached to this object. All right, so I can stop that. And yeah, so this is an example, just like the intro mode, of an activity that teaches me about the model using videos and annotations and audio recordings. But of course, there's another type of activity, which is the challenge. And this is where I get to test my knowledge that I've acquired so far about the object. So let's take a look at a challenge. So number 2 there, this is called the locate challenge. So let's go over to number 2. Okay, so it takes me to the intro page of the challenge, and I have a go button. This means that I can start the challenge when I click on the go button. Now, before I start this challenge, I want to show you guys another way to navigate this particular, on this application. So far we've seen a generic 3D view, but let's jump into the augmented reality view. So by clicking on the button on the left side there, AR, I start loading the augmented reality mode. And I get taken to a mode where you can see that my object appears on a little marker that I've placed on my table. And so I have a full view of the object in 3D. So let's go, I'm gonna go back to the intro for a second, just so we can see that we do have access to all the same functionality we saw earlier, but this time in a fully augmented reality mode. And my teacher, when they create this, really doesn't need to know anything about programming. Okay, let's go back to the locate activity and let's start it. So it's telling me that I'm gonna have to locate a particular part of the object. All right, so it's telling me, please locate this part, the compressor cover. Okay, now I'm not sure what part that is, so we can try this one, for example. Is it that one? No, it's not. So I got that wrong. I think it might be this one. Okay, that was correct. So my current score has gone up. So you can see that the score at the top left there, it says 3 out of 180. So I could have gotten 5 points in total if I had gotten this right on the first go. But because I got it right on the second go, I only got 3 points. So next we have a quiz. So we can click on go. And once again, it tells me what to do. It tells me that I'm going to have to answer the question. And it isolates a part of the model and asks me a question about it. So this question was written by my teacher. They also decided which part of the model this quiz would isolate. And let's see, what's the function of the compressor cover? So I think it might be air compression. Let's try that. Yes, so I got that right. And automatically, it takes me to the next part of the lesson. So in this case, this is another one of those teaching activities where it focuses on a part of the model and tells me about it using the recording that my teacher added, but also the video. So if I click on the video here, I have a really cool augmented reality video that starts playing. So let's close that. There we go. Okay, so that's really the idea behind the lessons in Creator AVR, is these very easy to use step-by-step activities that progressively teach me more and more about a certain object. And the last thing that I want to show you here is the VR virtual reality mode. And let's click on the VR button on the side there. So that's going to load the virtual reality mode. And so now that I'm in here, I can actually slip my phone into a head-mounted display or into a Homedo device and start experiencing my lesson in full 3D. So of course you guys are seeing 2 screens, but if I was wearing a head-mounted display, I'd see only 1 screen in full 3D. So I can tilt my head to the side to rotate around the model, tilt my head the other side to rotate in the other direction, and I do have access to all the same functionalities we saw earlier. For example, the transparency mode. I just look at an object, look at a button down there to turn on and off that functionality. There we go. And at any point, if I want to keep going through my lesson, I just look at the AR button or the touch mode button, and it takes me automatically to that mode, back to where I left off in the lesson. And then I can keep going through my activities until I've completed all of them. And at the end of the lesson, what's going to happen is that my score and all the things that I've done are going to be uploaded to the server for my teacher to see how well I did. And so that's an example of what a lesson looks like in Creator AVR. All right, let me stop mirroring my screen. There we go. All right, so I think I'm going to give the floor back to Britta because I've completed my presentation. I hope this gave you a good idea of what it's like for a student to experience the VR lessons. And yeah, so just a word about the teacher mode. From the teacher's perspective, we have a very easy interface of, first of all, I'm just going to play a quick video here and just skip through it. First of all, uploading models, automatically converting them to a format that's understood by AVR, and using those models then, once they're in the library, inside the lesson creation interface, and this is what it looks like. So it's kind of similar to what we saw in the student mode, but this is running on a desktop computer. And on the right side there's a new panel that that allows teachers to very easily create new activities for this particular lesson. So you can see here, for example, they choose the activity they want to add, and then they add it. So here, for example, my teacher has added a locate activity. He can then change how long this is going to take for the student, choose which part of the model it's about, in this case, the injector rocker. And then once he's happy, he can add another activity, and he can add as many as he wants until he reaches the point where he's happy with his lesson, and then saves it and uploads it to the portal, and then assigns it to his students. And yeah, so that concludes my presentation. I'm going to go to, where are we? There we are, the Q&A slide, and over to you, Britta.
Thank you, Terence. Thank you so much for your presentation. I see that we have some questions here, so let's get started. The first one is, what is MOOCs? Yeah, that was something that Professor Anderson mentioned in his presentation, and MOOCs stands for Massive Open Online Courses. And these are free online courses available for anyone to enroll in. And they provide an affordable and a flexible way to learn new skills and advance in one's career. And it's more also in addition to the traditional course materials, such as lectures, readings, and problem sets, many of the MOOCs provide interactive courses with a user forum to support the communication and interaction among the students, professors, and teaching assistants. Another question is, can many people, and if so, how many, can join one simulation to solve problems and work together as a group? Terence, that's for you.
So it is possible to do that. In terms of the number of people, there is really no theoretical limit at this point. So it really depends on factors outside of the application, like the internet connection, for example. So I would say that there's no theoretical limit for the number of people that can join in.
Okay, good. Thank you. What is the best way to engage with this kind of technology?
The best way to engage with this kind of technology would be to, let's see, in what sense, sorry, engaging with this type of technology? That would be my follow-up question on that.
Yeah, I did not get the follow-up question, but that's okay. I think it's depends on a little bit what you want to do, right? If you have students, you're probably going to have probably use a phone or a tablet, and if you have more advanced teaching, or then maybe you probably would use a head-mounted display, be more immersed in the environment. That would probably be my
okay, yes. So yes, in that sense, it really depends on the objective, really, of what you want to do with the technology. Now, for teaching purposes, like we just saw, I think it's good to use devices that are available to the masses, and those, a typical kind of device like that would be smartphones and tablets, and that's what the AVR platform uses at its core. But for more specialized purposes, like not so much in the education field, but more on the training side, perhaps, as you said, head-mounted displays, AR, augmented reality glasses, and like the Microsoft HoloLens, for example. And really, there's no one answer to this because it really depends on what we're trying to achieve with the technology.
Great. We get a lot of questions here about what kind of content that we can or that can be uploaded to the AVR platform, or the CAD format like CROE or CEO or PTC supported.
Okay. So yes, one aspect. There are two ways to upload your content, or three ways rather, to upload your content to the AVR platform. One is through our authoring tool called Eon Professional. So I briefly talked about that during my presentation, and that tool supports the importation of multiple different types of objects. So from CAD files like STL, other types of CAD files as well, OBJ, FBX. There's a whole list, which off the top of my head, I don't know by heart. But there is a list of at least dozens of different types of models that we can import. Any of the major 3D formats we can import. Now that's the first way. The second way is through 3ds Max and our plugin to that called Eon Raptor. Now that allows you to export from 3ds Max any 3D model that you might be able to import into 3ds Max. So any of the formats supported by 3ds Max, we support as well, because from there we export to our AVR format. And the third type is the automatic conversion online, directly on the AVR platform itself, where you can upload various different types of models like OBJ, FBX, CAD formats, or directly our format as well. And we have a service up there on the server that automatically converts models to an AVR format. So those are the three ways and some of the formats that we handle.
Yeah, perfect. Thank you. Yeah, we will also follow up with each and every one here that had that question, so we can make sure that you get the answer correctly there. Great. Also, when it comes to uploading, is there like a file size limit or a recommendation on the different individual modules?
There is no file size limit, theoretically. The only thing to be aware of is that these models are going to be displayed on smartphones, not on desktop computers. So when we do our automatic conversion, there is some optimization that goes into that. But if you're going to upload your own models that you created yourself from scratch and you're converting them yourself, you need to be aware of the optimization that you're going to apply to your model in such a way that it's able to run on smart devices that don't have the, the processing capabilities of a desktop computer.
Great. Another question here is about privacy. What about privacy of data for teachers and students in the cloud?
So for that, we really look at what it is that the particular university or the particular institution needs in terms of privacy, and then we implement a solution based on that. So it's more of a tailored process, but we always make sure that everything is completely secure and there's no way that anyone would access the data from outside.
Great, thank you. What about haptics and touch VR education? What is the role and possible use cases there?
So I think those would be more, okay, let's see, haptics. So that would be haptic feedback and having the feeling that you can touch something. I think first of all, let's talk about the technology there. The technology for realistic haptic feedback isn't really there yet. So we don't have easy to use or implement solutions, hardware solutions to implement that, to have that working well. But in terms of its uses, I could see that more on the training, like engineering and training, very specific training scenarios rather than a more general education scenario. But this is definitely something that's in our pipeline, in our roadmap. And as soon as the technology is good enough that we can implement this and deliver it to everybody, then we will definitely jump into it.
Great, thank you. Just we received some questions here about if the lessons can be used offline.
So that would depend on whether that is your requirement, basically. In the normal platform, no. You need to have an internet connection. However, if it is your requirement that the lessons be able to be used offline, then we can have some sort of custom development and add that feature to the platform and then roll it out.
Great, thank you. We are running out of time here a little bit, so this will wrap up the Q&A session. But please know that we will follow up with you if we were not able to get to your question. And again, we will also follow up with everyone with a link to the webinar recording. But feel free to contact us directly or via email at marketing@eonreality.com if you would like to get more information about the topics covered today. So even if you have more questions, don't be shy, just send them across. This concludes our webinar. We would like to thank our presenters for their time and willingness to share their information and experiences, and of course to all our listeners participating today. We are glad that you could join us and hope this session was helpful for you. Thank you and enjoy the rest of your day.
Thank you. Goodbye.